So today I'm on the road in CNETs and we got find eventual save states, directed graph and labeled nodes, graph I adjacent Leetcode coming up with the most dog shit graph representation. No outgoing edges. Starting leads to a terminal node. Then I guess 4, 6, but shouldn't. Okay, so it's a cyclic graph. Okay, fair enough. And so only 4, 5, 6 are safe. How is 2 safe? Okay, 2 is safe too. Okay, that's fair. What are the sizes of the graph so we cannot brute force? So well, what do you want to do in a situation like this? What's this graph? So from 0 you go 1, 2, 3, 4. You can go to yourself. That's weird. From 2 you go to 3, 4, and then from 4 you go to 4, 5. So only. Okay. So basically, okay, so this is the number of. Okay, so not so if a cycle is reachable, then we are cooked, right? So let's say we start at some node and then if we reach so basically we just mark the ones in cycle and everything else is the answer. So we just mark everything that reaches a cycle node with that's fair. So we need probably 3 colors. I don't know, let's see. nlen graph arch list for neighbors in graph okay, for j in graph I aj append j j append I, and then no, actually you don't want to do that, we have a directed graph, and then well, we have like I don't know what's the color, if color I0 DFSI, we got DFS non-local arch color. Well, what do we do? For u in HV, and now if so, let's say we come up to a unvisited node, whatever, we just go there. So we visit it, and then whatever, elif color u is 1. So let's say then we visit our pass for now, and then we are color is 2. So if we meet the cycle, yeah, then we color ourselves with we can reach a cycle, and then otherwise if we reach already visited node, does it mean that we are in a cycle? Not really. I mean, no, not really. Because I could just start it like a node that has some outgoing edges or incoming edges. So we only care that we visited it in this DFS. So if its color is 1, right, then we say that so for now, let's say it's from the same cycle. So if you are so tired. So yeah, that's bad. Okay, so if we visited the node, then we say that okay, our color is also 2. Right, and then when we go back, we set this u vertex, we visit it, right, and then if color is 2, then like that, I think. Now the only question that remains is that for v in comp, color v free, comp clear, ans for v in for I in range n, if color I2 ans append I think I am overcomplicating it and it will also not work. That is weird. Okay, so print I, print comp, print color, print I didn't want to submit. Okay, so we start with 0. And then we have 2, 2, 2, 1, 1. That's fair. Then we start with 4. Wait. Comp append v, if color v, that's fair. Or think there is none in the cycle. Okay. Okay, that works, kind of. Okay, doesn't. Great. So what's this graph? Why is one not in there? So after doing 0, nothing happens. After doing 1, what's that? Component is 1, 2, 3, 4. That's fair. And why is the color of these two? If v1 print vu. So what I'm doing is I need to debug the wrong thing is that for some reason this is set to 2, which I don't know why after doing the DFS. So one, two, three. So I get them. What the hell? Print v color. So I'm at 1. So I am at looking at zero free Okay, so I need to have like a color also if it's on stack, right? So if not visited, let's have visited on stack in cycle processed 0 1 2 3 4, right? So this is on stack, and then if color v on stack color v visited, if color visited, then color is equal to processed. Great. If color is not 2, means in cycle. So now if we visited node, and if it is in cycle after that, then we are also in cycle, right? If we visit a on stack node, then we are in cycle, right? If we visit in cycle node, then we are in cycle 2. I'm not sure what I'm doing at all. Output limit exceeded. There is no way this works. What am I even doing? Topological sort? But how can you do topological sort on a graph, bro? What the freak? Okay, that looks simpler. Okay, seems a little bit simpler. this scan algorithm. Oh, so you start at terminal node and then you look at their parent, so you mark terminal nodes, right? The ones that don't have outgoing edges. And then you look at parents, and if parents go just to marked nodes, okay, then you can add the parent of the node there. Okay, that's a little simpler. Whatever. Let's write out my absolutely 10 times more complicated simple-ish DFS. Okay, so to find nodes that do not have a path ending in any cycle. With a DFS we can find the opposite edges by marking the visited nodes, but I really shouldn't, because this processed sheet is absolutely useless. Yeah, this should just not exist at all, and then get that a little faster. Okay, that's a little better. Then I guess this happens otherwise, maybe. Okay, no. What can we can have not visited. Sorry, if it's visited. Elif color you visited, maybe like that should work. That will not help with anything, but it's not a dog water at least. Okay. Let's do that with a DFS. Start, go through all unvisited nodes, go through all nodes and start in any unvisited a node. We find a cycle if any of the neighbors of the checked vertex are on the DFS stack. A vertex we therefore just mark vertices or if it's already in a cycle. We therefore just mark vertices with colors 0, not 1, visited 2, on stack, 3 in cycle. When we visit a vertex, we first mark it on stack. Then as we visit the neighbors, if the neighbor is what? If the neighbor is not visited, we visit it, and when we return from the recurse DFS call, we check if it's inside a cycle, since all nodes that since we want to if its color is in cycle from all nodes from which we can reach a cycle, i.e. a node in a cycle. If the neighbor is not visited, is not was already visited, we set the current vertex into in cycle. We set the current vertex color to in cycle if the neighbor is on stack or in cycle. Finally, after going over all neighbors, if we were not set as if the current vertex was not set as in cycle, we set it to visited, that is when another node reaches it. Now the node that reached it will not be marked as in cycle, otherwise we would mark nodes in cycle in graph 1, 2, 3, 3. Where m is the number of edges and n is the number of vertices, since we just do a DFS. Finally, the answer is all vertices not colored by in cycle, since we just is the number of vertices with a couple O1 operations per node n plus n, since we store the graph as an adjacency matrix. Okay. Okay, that's it for today. Goodbye.